Hey guys, welcome to Algo Forces. So today we will be going ahead with Leetcode problem number 1015, that is smallest integer divisible by k. So what I'll do is I'll just go through the description once. I'll explain you what the problem wants, and then we'll move to the example, and then we'll move to the coding part. Okay. Okay, so let's begin. So it says that you are given a positive integer k. You need to find the length of the smallest positive integer n such that n is divisible by k. Okay, and n contains only digit 1. So let's say here we are given k equals to 1. So which is the smallest integer such that that integer contains only digits 1, no 2, no 3, just 1, and such that that particular integer is divisible by k. So it is 1 only, right? Like other possible integers are maybe 11, 1, triple 1, and so on, but the smallest one is 1. Okay, now let's see for k equals to 3. So for k equals to 3, see the number of possible answers are like the smallest number is definitely triple 1 because 1 is not possible here, right? Because 1 is less than 3. Okay, so triple 1 is the smallest possible answer as triple 1 is divisible by 3. Okay, so now let's see how to approach this type of problems. Okay. Okay, so we have these three examples k equals to 3, k equals to 2, and k equals to 7. So there are two possible cases in this example, like whether we can produce a number which is divisible by k, or we cannot produce a number which is divisible by k, like for here k equals to 2. So we cannot have any number like any number that is divisible by 2, because the possible numbers which we can make with two with digits 1 is 1, double 1, triple 1, but none of them are divisible by 2, right? So we will just return minus 1 in this case. Okay, and similarly here the possible number is the answer will be 6 times 1. You can yourself check if this is divisible by k or not, and you can also check whether you can produce any number which is less than this such that it is divisible by k. Okay, so now let's start with the approach. So I'll start with k equals to 3. So I will have one number variable. So I'll start from n equals to 1. I'll just pull up one single digit 1, and I'll see if it is divisible by k or not. Along with number n, we will have L, which will denote the length of the number which we have generated. And this another variable. Okay, I do not need any other variable, but here I will display you the number which is generated by us. Okay, so initially n equals to 1. Okay, so is 1 divisible by 3? No, right? So now we have the remainder as 1 again, because 1 is not divisible by 3. So now what I'll do is here initially the length of the number which we have generated is 1, because we only had 1. Now I'll pull out another 1 here. So the length I will increase by 1. So here the length will become 2, and the next number is double 1. Okay, so is double 1 divisible by 3? Again, no. So what is the remainder? The remainder is 2. Okay, so now I'll pull up another one, and I'll increment the length by 3, because we have pulled up 1. We have pulled up 3 ones as of now. Okay, so is 21 divisible by 3? Yes, it is, right. So the final generated number is triple 1, and it is divisible by 3. So okay, so now let's go for k equals to 7. So similarly I will just have a number variable, and i can also have one I can also have one length variable for indicating the length. Now I'll start from n equals to 1. Is 1 divisible by 7? And the length is 1 initially. Is 1 divisible by 7? No, right? So the remainder is 1 again. So I will pull up another one. So length will become 2. Okay. Is 11 divisible by 7? No, right? So now the remainder is 4. Okay. And now I'll pull up another one. So the length becomes 3. Okay, so is 41 divisible by 7? No, right? 7 fives are 35 and the remainder is 6. Okay, now I'll pull up another one and the length becomes 4. Okay, so is 61 divisible by 7? Again, no, right? Because 7 eights are 56 and the remainder is 5. Now I'll pull up another one. The length is 5 as of now. We have seen 5 times 1 so far. We have seen till here. I am pulling up another one. And is 51 divisible by 7? Again, no. Okay, so the remainder is 2. I'm pulling out another one. So we have seen 6 ones so far. Okay, so is 21 divisible by 7? Yes, right. So basically, this is the answer. This is the final answer. Okay, so one important thing to notice in this k equals to 7 example, like this 1, 4, 6, 8, 2, 0 being the different remainders. So there is one thing that if k equals to 7, then what will be the what will be the possible remainders for this? It should be either 0, 1, then it can be 2, then it can be 3, then 4, then 5, and then 6. Can it be 7? Can the 7 be the remainder in any case for k equals to 7? No, right? Because it means that we are yet to divide it one more time. So k cannot be equals to 7. Sorry, the number of remainders it should be equal to 7. That is 0, 1, 2, 3, 4, 5, and 6. So basically, the total number of remainders should be equal to 7, and the maximum possible remainder should be less than 7, right? So this is one thing which you should notice. So coming to the k equals to 2 case, okay. So we are having 1 initially, the remainder is 1, then we are pulling out one more 1, but again the remainder is 1. Then we are pulling out one more 1, again the remainder is 1. But we had seen before that the total possible number of remainders for 7 should be 7. So for 2 it should be 2, right? But here it is exceeding 2, that we are getting before getting the number which we want to get, we are having three remainders, right? So it means that we cannot find any number which 2 can divide. Okay, so that is what we can see from here. Okay, so this is one of the things. So we will, if so, basically, if the number, if while dividing, if length exceeds then k, okay, so then we will straight away return -1. Okay, I hope this is clear to you. Let me just reiterate. So basically, here is the length is exceeding k, right? That is the total possible number of remainders is also exceeding k here, right? That is, it is coming 1, then it is again coming 1, and then it is again coming 1. So we can realize that this we cannot have a number which can be divisible by 2, and hence we will return -1. Okay, so let's start with the coding part now. Okay, so what all we need is, we will need one length variable initialized to 0. We will need one num which is initialized to 1, and we will need one remainder variable which is initialized to k. Because initially we have not divided, so the remainder will be initialized to k. Now I will loop till remainder becomes equals to 0. So if remainder is equals to 0, then this will break. Okay, now remainder equals to num modulo k. Okay, now num will become remainder into 10 plus 1. We are pulling out 1 here, and we will increment the length. Okay, so now this step, that is, let's say the remainder was 5 and we need to pull out 1, right? So basically we are dividing 5 into 10 and we are just adding up 1 year. So this is what this step is. Okay. And for just making sure that this doesn't end up into some infinite loop, so we will have one more check, that is length should be less than equal to k. Okay, so this is one more check needed, because if length becomes greater than k, right? So it means that we have the total number of variables greater than k, and it means that some of the remainders are getting duplicated, right? So basically, let's say for the case of 2, so let we are having 1, then we are having double 1, and then we are having triple 1. So the remainder goes like 1, then again 1, then again 1, but and so on. So basically here to total number, if the total number of remainders it is, if it is greater than k, that here if we see three ones, right? If we see the three remainders, then we can be sure that here the some of the remainders are repeating, as we can see in this case, right? So this is why we have added this check, that is length should be less than or equal to k. And then the final step, if remainder equals to 0, then we will return length, else we will return -1. Okay, so let's try to run this code now. Okay, so it is working, and then let me try to submit this. Okay, see, so this worked. So this is all it is, and here the time complexity will be big O of n, and the space complexity will be constant, as we are not having any arrays or something. So I hope this approach is clear to you. So in case of any doubts, you can just comment out in the comment section, and please do like and subscribe. Okay, then have a great day. Bye.